Hello, Maurieo. This is another one of my videos where we're going to use or simulate a survey traverse situation, and this one's slightly different. So first of all, let's have a bit of a look as to what we're going to do. So what's happened here is we have a lot here, the larger lot here, which we're going to split into two lots, lot 1 and 2, and we're going to make the boundary coincident with this fence line running through here. We have taken ties onto posts 1, 2 and 3. Post 2 will become a boundary mark, and we will be placing pegs on the intersection of the fence and the boundary here, in which a peg here and a peg there. So just how we go about it: first of all, we have two marks along here, which we have known bearings and distances for those, and obviously ties out to some old pegs which define this boundary. So we've lined a mark in here, we've traversed down here onto another mark here, which is lined in between these two marks. So we have a bearing origin, if you like, perhaps down here, come through, and we've closed on to another origin here. In this case, we have coordinates for each of these 4 known points, so we're going to close between here and here, close out our new traverse, calculate our pegging ties, or calculate our pegging ties along our boundary by way of an intersection, and we're going to calculate those ties, calculate the new boundary lines, and then work out the area of lot 1 and lot 2. So let's crack on with that then. Okay, so here we are with our new project, and first thing as we do is like we did in our first one that I did, this is the second one of these I've done, we'll just set our projection, and in this case here the projection that we're going to be using is the Bay of Plenty 2000 circuit once again. So we'll just click in there and set finish. So that's set at the Bay of Plenty 2000 finish. Okay, now the next thing that we're going to do is to get our traverses sorted out. So it's just up here, survey and traverse spreadsheet. We will probably just look at our parameters here, just to see that they're pretty much the same as what we had last time. So this is setting off the rounding off for any inverses down in here, as we say, and up in here we're going to have our 2 decimal places. We're not doing any arcs, and the decimals for coordinates is 2 decimal places here, and this just details around our traverse sheets. So that all seems pretty fine. So yeah, we'll just pretty much not going to change that, so just leave that how it is in that setting that it came, and then we'll just go survey traverse sheet, and we'll create a new traverse sheet up in here, and the network name for this one, we'll just start off, we'll just call it traverse 2, because this is the second one, similar ones of these here, and traverse 2, and create. So there's our traverse sheet, and we'll just put that into there and make that fit the available size that we have, so that we can show ourselves a lot of information. So the first thing we're going to do, I'll actually start down the bottom because there's iron spike 1. So the first thing we'll do is we'll start with a start point of 1, enter, and I'm putting in the coordinate for old iron tube 2, which is down the bottom of there, which is 806.231.30. I've got a copy of the plan, a hard copy of the plan here in front of me, and I suggest that you might want to do that by either printing off a screenshot or you can email me and I will send you a PDF copy of the plan that you could use if you wanted to follow through this exercise. You can find me at my website on www.maurieo.com or email me at maurieo@maurieo.com. So I'm going to go into here now. One of the quirks of this sort of program as it is that you need to actually just go down in here and put this coordinate in here as you start. So I'm going to put in there, this is the final coordinate, so we're going to traverse from old iron tube 2 to old iron tube 3, 806.298.69, enter, and 309.823.88, and that's old iron tube 1 3, enter. So, and then in here we're going to go to, now that's putting in there 0.2, but I've already put that in as the end coordinate, so I'm going to put in there 3 because that's going, and we've got 65.31 for the bearing and 81.37, and that is a traverse, and we're going to iron spike 1, enter, and then we were going to close off on 2, which should be 61.31 again, and 81.24, enter, again that's a traverse. I'll just leave that like that and just close that off, and oh, it's not liking that too much. We just better have a bit of a check out there and see what we've got. So we've got 806.231.3, and oh, I see what's gone wrong there, and 806.231.3, and that should be 309.675.90. So I put the wrong coordinate in there, and obviously we've got some quite large errors there, so let's see if we can count that now. And still got a bit of a problem there, 61 degrees, oh 65 degrees, so making a lot of little boo-boos here, 65 degrees, but all the good. We can see how our program, so let's calculate that out. Oh, now that's a little bit better, but nonetheless we should check everything. 6531, 81.37, and 6531, 81.24, 806.298.69, 309.823.88, and I'll just check these again, 309.675.9, and 806.231.3. So that's everything, seems to be in order. Just save, and that's an 0102 close, 1 in 6,000. That's pretty good considering what's happening there. So I'm happy to accept that, and we'll just turn our layers on there, and just looking in here, we'll just change our point IDs. That's giving us our numbers, and in here we will put in our string names just to help things along. Alright, so next thing to do is to go up to the top, and we'll do a new block. Again, it's a traverse block, and this point here we've obviously got 1 2 3, so this will be 0.4, and we'll try and get the coordinates in right this time. 806.347.23, enter, and 309.634.58, 309.634.58, and that's old iron tube 5, enter, and as I did previously, I'll put this one in here as 5, and this will be 806.400.78, enter, and 309.779.07, enter, and that there will be OIT 6. Okay, and now we'll traverse to iron spike 3, which is coming in as 5, but we've already used 5, so we're going to call that 6, and that will be 69.3950 for 81.56 meters. Again, that's a traverse, and that is iron spike 3. Okay, and then we're going to track that or close that onto 5, which is 69.3950 for 72.54 meters, and that would be old iron tube 6, okay, in there, and let's see if that closes up. Oh yes, 02, 01, 02. So again, that's a fairly suitable sort of close. So we'll calc, adjust all, and save. And there we are. We've closed off our 2 marks. Now it comes to the point where we're going to traverse between the 2. So we'll start at point 3, which is iron spike 1, and we're going to go, oh, that should be 03 seconds on the diagram there, 148.1303, and for a distance of 75.67. I'll have to fix that up perhaps a bit later on, but I have forgotten to put the leading zeros in and round that one up, but that's what it's going to be. And so and that's TR, enter, and that will be to iron tube 2. Okay, and oh, that's gone the wrong way, 348, so that needs to be, obviously 148 is there, so it's gone 180 degrees out, so that will be 328. Okay, and then we'll go from there. Oh, we can just adjust all. It sort of fixes that up there, and we can go from here, enter, and again 181, which will be 1.1110, 1 degree 11 minutes 10 for 46.24, and that will be actually not to 0.8 but 2.6 that we've fixed previously before. So let's just calc that. Oh, didn't like that. 6. Calc. Oh, there we go. So you just got to make sure that things happen how they should. So 328.13. I think that should be 30. I'm going to, yes, make that 30, I think, and 75.67, enter. So let's calc, adjust all, save. So that's going to be 1330. I'll fix that up a bit later on, although it'd probably stay incorrect in the video. So again, when you're putting stuff into your traverse, again, sometimes you find out little anomalies in your field data that you have to go back and check. So it's sort of modeling that a little bit there. Okay, calc, adjust all, save. So what would be the next step, I think, here would be, I was going to put in all my radiations now. I think, as I've said in my previous video, what I like to do is my survey information is done as hold, so I hold that with no actual error in it whatsoever. So let's start at, I'm going to do a number of radiations now. These are radiation blocks, so I'm going to start at point 1 and put in the radiation block 288.15, 288.15, enter. 34.57, enter. So again, I've got a little bit of a problem there in that I haven't rounded that appropriately, and this will be TR like so. And oh, sorry, I've gone a bit wrong there. I should put the 1 in there, and then this here would be I'll just delete that and push enter there, and that will be to 0.8 to 88.15, 34.57, and that's to that'll be a Travis, and that will be to old peg 4. I'm going to call that. Okay, calc, adjust all, save. Now, to save you the bother of watching me put all of this information in, what I'm going to do at this point in time is pause, and I will put all of the radiations in as separate blocks, and perhaps run you through the blocks when I get back. So I'm just going to pause the video now. Okay, so that's that done there now, and that's all the radiations been put in, each one with a separate block. So what I like to do now is just to I'll close out my boundaries. So I'm going to just go into some Travis blocks and close out the peripheral or the existing boundaries. So that will go from 11, from old peg 1 to old peg 2, which is 0.13, and 680520, and it comes up there as 223.68, but the old value 223.70. Put that in there, and that'll be BR for road. I'm not worried about whether adopted through at this point. Calc, that's perfectly fine. It's well under 03. 1 in 9,000. I'm going to accept that. Adjust all. So I'm going to accept that as the boundary, and that I've correctly tied to and identified the old peg. The next one I'll go from is 13 through to, which is old peg 2, through to 0.10, which is old peg 3. 168 degrees 2930 is calculating at 168.2920 is what the old value is, and 77.74, and again that's just that's going to be a boundary existing. I'll put in there as opposed to being a road boundary, and we'll calc that. That's fine. Nice close there. Adjust all, save. So as we go along, everything is closed out and accepted before we move on to the next one. So if we identify any problems, you know, they're sorted out before we move on. So then there's the next block, which we're going to go from old peg 10, which is old peg 3, which is 0.10, through to old peg 4, which is 0.8, and that's 245.4630. I've got 245.4630 and 210.08, and that's a road boundary, BR. And let's have a look and see how that goes. 03, you know, that's still fine, and it's a 1 in 7,000. So it's, you know, anything over 1 in 4, 1 in 5,000 is generally okay. Adjust all, save. And then finally, we'll, for our existing boundaries, we'll go to the next one, which is from 8, okay, to 11. And 158.1510, 338.1510, that's acceptable. 84.95, 84.95. Enter, and that's an existing boundary. Okay, so let's calculate that. Calc, adjust all, save, like so. So that's that all done there. Now what I like to do now is to occasionally we're asked to save the project here, so I've saved it there. So what I want to do now is to calculate the intersections. So what I find, and I can see here that I've forgotten to put in the radiation from iron tube 2 to post 2, so I'll just quickly do that now. So that's a radiation there, and the start point is 0.7, which should be iron tube 2, and we're going to 0.14, and that's 80 degrees 58 minutes, 80.58, and for 36.09, that's a traversing there that we've done, and that will be post 2. So I'll just put that in. I forgot to do that. Adjust all, save. So what we're going to do now is to calculate these intersections in here, and there's various ways of doing that, but what I like to do is to well, I have a way of doing it that suits me, so we'll just have a look and see how that all pans out. Alright, so what we're going to do here is I'm just going to add a couple of lines, or the fence lines actually, for construction purposes in this case. So just go here to the little line, the line thing here, and create a line. And I'm going to create a line between that point there, except, and this point here, except, and between there, except, and between there, except, and they will be in the base layer, because that's what's indicated up here, so they're just there for construction purposes. Now what I'm going to do is to just do some intersections, and just to see how things fit together. So first thing I'm going to do is I'll just change that color there to magenta, so when I create a point in here, it'll be there, so it'll come up magenta, it'll be in the base layer at this stage. So I'm just going to go strings, CAD, intersect, and I'm just going to go segments, and I'm just going to accept that segment and that segment there, and that creates a little point in there, as you can see. And while I'm just in this feature, I'll just accept that one there, and I'll accept that one there. Okay, so that's created approximately where the 2 points are going to go. So what I'm going to do now is for each one of those, I'm going to just measure the distances down to each one, and I'll just write those down. So just got to go and find a pen, and I'll be back. Okay, I'm back with my pen in hand now, and I'm just going to use this little feature here which measures things. So if I just go from OPEG 1 and measure through to there, except I get a distance of 123.72. So I'm just going to write that down, 123.72, and then I'm also going to then clear that and measure the distance from here through to here, accept, and that gives me a distance of 99.98. 99.98. Now I'm going to add those together, and it becomes to 223.70. So that's fine. I can use those two distances. If they don't quite come to the underlying one because of various errors in that, I just add a little bit proportionally to each one so that they end up in the same relative position. So let's just move that out of the way, and I'll just clear, and I'll just measure from here, except through to here, and there I'm getting a distance of 121.34, 121.34, which I write on my plan, and clear that, and then I'm going to go from here, except through to here, I'm accepting the elliptical distance. That's the ones that we work with. We work with elliptical distances. These are the ones that take into account or are based on the ellipsoid rather than the plane distances, with it, which are just straight between the coordinates. In this case there's no difference. 88.74. Now if I add those together, 88.74, I once again get 210.08. Now it's important that you do get them to equal the total of the underlying ones there, and you'll see why in a little minute now. So that's our intersections done. I'm just going to finish there, and I'm just going to go, what I'm going to do now is go back to our various blocks. So if I just click on that one there and click on that line there, accept, it goes back to that block, and it's going from 11 to 13 and 68.05.20. So what I'm going to do is I'm just going to introduce another line into this block here, and I'm going to give that's going to be a new point number, and that's going to be 68.05.20, and I'm going to put in the 123.72 that I measured, and that's going to be a calculated distance, and that will take us to what I'm going to call peg 1. Peg 1, enter, and I've called this, I'll just put a little space in there, peg 2, and now we'll just look at that. It's the misclose should stay the same, so I just go calc. Oh, I've forgotten to change this here. This value here I'm going to change to 99.98, which is what we measured there. Sorry, and we'll change that to calc as well, and then change that to old. Now that won't change to OP2. We've got to change it there, I think, or in its actual original one. It'll keep recap. So yes, it'll keep recalculating it there. So there it is there. And that's put peg 1 in place there, and it should be on the same line as the fence there. There's various ways you could check that. I'm not quite going to do that now. So I'm just yes, I've seem to have relabeled old peg 2 correctly there now. So calc, adjust all, save, and that's all very good. Yes, if you want to rename a peg or something like that, sometimes you have to go right back to the source point of where you named it. So now we've got another block here, and that's this block here. I'll just accept, and that takes us to there. Once again, we're going to put in another row there, and it'll be the same 245.4630. Important that you realize which way these are going. So 245 is going down the way, so that's going to be 88.74 in there, which I measured, and that will be peg 2, and then of course this will be the 121.34 CA calculates, because I've recalculated that boundary, I suppose. Calc, adjust all, save. So I fit it into the thing without too much change, and it tends to agree there with the with the point number. We can see there how it's all worked out. So that's one way of how I work out my intersections. Now the next thing to do, there's a couple of things to do. Perhaps we'll work out our new pegging ties for this. So we'll yes, work out our new pegging ties. So just put in a new one there. These will be a radiation, slightly different sort of radiation here. So we're going to go from 3 iron spike 1, and we're going to go 2.16, and that's our pegging tie for that. So I'll put that in as a TR because we're going to be measuring that. So there's our pegging tie to from iron spike 1 to peg 2 to that boundary point. We're going to be going back and putting that peg in, so we'll just calc adjust all, save, and then we're going to go to a new block here and calculate our pegging tie from iron spike 2, which is 0.6 there, so there's 0.6, iron spike 3 to peg 1, which is 0.15, 118 degrees 39, 17.46. We'll be traversing that peg in when we next back on site. Calc adjust all, and there you are. We have calculated our pegging ties, and then we will put in our new boundary. Just check out our new boundary bearings and distances. We'll put them in as I've already put the other ones in, as I showed you earlier, by inserting them in the block. And now we will calculate some new boundary bearings and distances here. How you do those, there's a couple of ways you could do them. Just calculate them directly as radiations, I suppose, or you can do them as a traverse. Perhaps as doing them as a traverse is quite a good way of doing it. You can go 15. So we're going from peg 1 to post 2, which is 14, and that gives us 148.58 for 37.56. Call that BN, enter, and we can just calc adjust all, save, and that's got a very good close on that, as you would expect. And let's do one more here, and that would be from 14.14 through to peg 2, through to 16. I've called it peg 2, perhaps I should have called it peg 3, but we've got post 2 and peg 2, so they're different mark names. There we go, and we'll call that BN for boundary new, and calc adjust all, save. So there you are. You've got your boundary bearings and distances in there. All that remains now is to calculate out our two lots. So we go to here and we go to traverse and we put them in as a parcel, and I'll just call this one lot 1. Okay, there's other bits and pieces that you can put in there that are relevant when you putting information into Land Online, but and it's always been my custom to try and start from the westernmost point, because that's what I was taught to do when I first started. So I'm going to start from 15, like so, and so this is a pass 15 to 13, like so, and then through to 10. I've got that as CA. Sometimes you might want to put them as B boundaries or things like that for loading them or getting the XML right, but at this stage here it's probably fine. Through to 16. I'm just treating these as calculations rather than as an input exercise into Land Online. 16, yeah, it all seems to be good. 14 through to 14, like so, and then through to 15, and we can calc that out now, and that gives us an area there for lot 1 of the ellipsoid area 7076. I tend to keep them down low, 7076 or 0.7076 hectares for that one there. Also, so then we'll go to lot 2 here, and we'll start at the westernmost point, which in this case here is just 11. So we put in 11, which gives us old peg 1, to 15, which gives us through to there, through to 14. Yes, and through to 16, and through to 8, I think it is. Yes, and then from there through to 11 again, and that's calc and adjust, and that gives us an area, ellipsoid area there of 10,389. So that's 1 hectare 0.0389. Never remiss to do a bit of a check in these situations, so I might go ahead and just do the whole initial, so I call it initial, the initial block, just to check that the whole thing is going to pan out okay. So we'll just do the whole thing again. I always start at the westernmost corner, so that's 11. I'll peg 1. I'll put peg 1 in because it's now on the boundary, so that, and it helps to record those distances. 13, of course, there, so it's all working out fine in terms of the 10 there, 77.74, and then we're going to come down to peg 2, which is 16, like so, and through to 8, I believe it is, and back to 11, and we'll calc that, adjust all, and save, and that's going to give us an area of 1.7467, and if we add our two bits of area together, 1.0389 plus 0.7076, 6 and 9 is 15, 7 8 is 15, 6 5, 1.7465, with the sum of the parts and the wholes. A very small discrepancy there, which is I think we can say is more than acceptable, and a reasonable check on what we've done. So that's like so. So that's all of our things done. Now if we want to, as I said earlier, get out a copy of the Travis report, we just go to Survey, Travis Sheets, New Zealand Report, and we fill in this detail here. Our input file will be Travis 2 is the one that I've put in. Travis is of, I'm just going to call this Kelly Road, the New Zealand Circuit. Of course, these need to be filled in. If you're going to be using formal Travis sheets, GDEC 2000, although it doesn't help to have have this sort of information in. It's in the South Auckland Land District, and we'll call this one TRAV Trav 2 TS for Travis sheet. And now no, we don't want to report parcels. Might report the point numbers just for this, because this is going to be a check and report, and that file's created. And then we'll just do one where we're reporting the parcels, and that will be, give that another name here, which is PAR, and report, finish. Now if we want to go and get the reports, we just go up here to report, edit, and then we click on the various reports that we want. And I will just pause here, and then I'll show you those reports as they become available, just to save a little bit of time and what have you. And so here we have our Travis report for Kelly Road, just recording each of the blocks that we did, and the radiations and whatever that we put in. It's covered over 2 pages here like that. So yeah, just get that and get that printed out, or you can just store it in a digital format. Just file, save as, and I'll put it in an appropriate place. Survey computations, Travis sheets, just put it in here, and Travis save. We can save it, or later on I can recall it from where it is and spit it out in PDF format. So here we have our parcels report, lot 1, with the everything displayed there, as we said, and then the total there. So there's the copy of the 3 things. We can always, as I said earlier, just file, save as, and we can put that in a file, or just through normal functionality put that in a file where we like, or I can just leave it in the format that it's in and call it up in the PDF format, which I will probably have available on the site in conjunction with copies of this video. And so we'll just cancel for now, and yes, we'll save the changes. Yeah, so there we are. We have our little Travis sheets all done, some examples of intersections and how we might go through that. So it's just a little bit of a thing on how I do Travis sheets, or bits of it. Obviously I've chosen some pretty simple examples, and it does get more complex than that, believe me, but and they're a good starting point. So cheers, and have fun with your surveying.